in our last lecture. If you remember, we have talked about the different states of the fluid and its phase diagram. We had the compressed liquid, saturated mixture, superheated vapor, and then we have talked about the difference, the saturation temperature versus saturation pressure chart. That this was an exponential chart, and also we have talked about the T-nu diagram, and as well as there is P-nu diagram. That we are not going to use the P-nu diagram a lot, but this one is the most important one. And then we had said that the pressure is an important variable, because that if you change the temperature from one value to another value, you could have a different phase change. For example, if the pressure is very low, you can move from the solid state to vapor state without even passing from the liquid state. Okay? And if the pressure is, for example, 1 atm, you can move from solid to liquid and then the vapor state. So therefore, the pressure is an important player here. So you should take the pressure into account when you have the temperature change. So then we have said how there are different tables, A4, A5, A6, and A7. And in one part you have the saturation temperature, then you have the saturation pressure, then you have the specific volumes, and then internal energy, and the differences, which is shown as UFG. Okay? And we have said that F means when the water starts boiling, and the G means when the ends boiling, and the U is the energy of the all intermolecular energies, intermolecular energy of the molecules. Now we are going to solve the example that we have left, so I will continue from that example. And here it says that, the temperature is 5, 15, and the 10. So this is the chart that we are going to look at it. So if you remember from the previous lecture, the temperature is 10 degrees Celsius, and the pressure is for that temperature. So these are the boiling. And then you have the saturated liquid line, saturated vapor, saturated liquid in internal energy, and as well as saturated vapor internal energy, and the difference in between. So I will start from the first one. So I'm not going to talk about this part, because in case you forget what we were talking about, I will start from the first one. So if the saturation pressure is 14, let me show you with a piston cylinder here. So you have the pressure, which is the 414.89 kilopascals. That's the pressure. And here you have the temperature, which is 10 degrees Celsius. Okay. At this pressure, at this temperature, the refrigerant boils. Okay. So if I decrease the temperature, to 5 degrees Celsius, so it is evident that it will stop boiling. Okay. So if it stops boiling, then you will have there are actually 3 regions, if you remember. One region is the compressed region, the other one is the saturated region, and the other one is the superheated region. Okay, this one has the highest energy, the superheated one. The saturated one has the medium energy, and the compressed one has the minimum energy. Okay. So if you think of the energy terms, so this one has the minimum, this one has the medium, and this one has the highest energy. So if it boils at 10 degrees Celsius, it means that in 5 degrees Celsius it cannot boil. Okay, so 10 is here, 10 degrees Celsius. This boils at 10 degrees Celsius. If the temperature is less than 10 degrees Celsius, then it means that you are falling in compressed region. And you are in compressed region, therefore you cannot have boiling here. And first temperature is equal to compressed region temperature. I can give you one simple example where for the similarity for the water, for example. Say that I have a water here, so that water temperature is 100 degrees Celsius, pressure is 1 atm. So everyone knows that the water boils. If I decrease the temperature, for example, say that now the pressure is 1 atm, temperature is 90 degrees Celsius. So it will stop boiling. So if it stops boiling, so it means that we have moved from one region. In this region, so under this curve, whatever we have is boiling. Okay, so saturated means it boils, that's all. So if you are not in saturated region, if you have less energy than the saturated region, then it means that you are in compressed region. Therefore, you are falling in that part of the curve. Okay, so just 1 minute. 1 minute. Okay, now for the second temperature value, let's see the second one. Now the temperature is 15 degrees Celsius. Let's see what happens when the temperature is 15 degrees Celsius. For the saturated region, which is the region under this part, under this curve, in that region, the temperature is constant for phase change. So you remember from the water, we have said that water here changes phase and the temperature is constant. And if the temperature increases, then it means that you have moved from one region to another one, which is the superheated region. So in that case, for the refrigerant one, if it boils at 10 degrees Celsius, if it boils, and if you increase the temperature from the 10 to 15 degrees Celsius, it means that you have gone the boiling part, you have finished the boiling part, and now you are heating only vapor. So only vapor here. So I hope you understand. If you go back to the water example, at 100 degrees Celsius, 1 atm, water boils, okay. After some time, you will see that there is only vapor here, okay. And it will be 1 atm, but only vapor, okay. If I continue heating process, then the temperature will increase. Temperature will increase, for example, 120 degrees Celsius, but it will be only vapor here, okay. So if it is only vapor, and if it is more than the saturation temperature, then it is superheated. Next one is superheated. But you should remember that I am doing example for the refrigerant, where you have the saturation pressure of 10 degrees Celsius and the pressure of 414 kilopascal and the temperature of 10 degrees Celsius. I'm not doing the water, just the water is for similarity. Okay, now comes the second temperature, which is the 10 degrees Celsius. When the temperature is 10 degrees Celsius, this one will be at saturated region. When the temperature is at 10 degrees Celsius, this one will be saturated region. Okay, because it is the same temperature as the one here. Okay, the saturation means boils. Okay, if it is 10 degrees, it boils and the region is saturation. Now comes the negative 40 degrees Celsius, and then now you can see that it is less than the boiling temperature. And if it is less than the boiling temperature, you can compare with the water, or you can compare with the refrigerant itself. So, for example, I've said it, for water, if it's 100 degrees Celsius, it boils. If it is less than 100, it will stop boiling, and it will be liquid. And that liquid is called the compressed liquid. Similarly here, if it boils at 10 degrees Celsius, if you drop the temperature, it will be compressed. Okay. Now the next one. So if it is at 18 degrees Celsius, which is more than the boiling temperature, so if you go back to chart here, so that at 414.89 kilopascals, the boiling temperature is 10 degrees Celsius. If you increase the boiling temperature, it means that you are in superheated region. Okay, so that if you are above the boiling temperature, actually, you are in superheated region. Therefore, the 18 is superheated. And the last one, which is 58 degrees Celsius here, again, similarly with the 5, it will be superheated. Okay, so these are the regions for the temperature. Now I will not do the enthalpy part because that will be a different one. I will talk about it later. Now I'm going to talk about the specific volume That will be a very important one, and then the pressure. So just 1 minute, I will add slide here because I've run out of the slide. Okay, now I'm sharing the screen with you. Okay. Now we have the second part, which is a specific volume. Now I'm going to talk about the specific volume values here. So I will draw the chart again here because the chart gives understanding what's going on. Okay, and in that chart, if you remember from our previous lectures, we have said that the one line is, for example, this line, and then you will have that line. Now, this part of the line where you have it, it separates. So let me show you. This line here, it is called the saturated vapor, saturated liquid actually, sorry. This one is saturated liquid. And then you have one more part of the line, which is called the saturated vapor. Okay. The values at saturated liquid line are shown with F here. These are shown with F. And the values at the saturated vapor line, they are shown with the letter G. And then you will have this part where you have the constant temperature, and then you will have the increasing value of the temperature, and then the decreasing part. And the process goes in that direction. You can also reverse the process. It's not a problem. This one is the temperature. This one is the specific volume. And for this line, along this line, pressure is constant. Pressure is constant. Okay, and this point, I've said it, it is F, and this point is G. And the region to the left of it, this region, let me hatch it so you can see it, what is going on here. This region here, it is the compressed region. The region that is in between here, it is, this part is the saturated region. It will be difficult for you to see the color here. So the region here, it will be saturated region. And the region here, that is from this side, all of the parts here, it is superheated. Okay, now let's solve the specific volume values. The specific volume nu F in the question it is given as 0.00079330. Let me show it at this point. It's 0.0. Actually, here you don't have any space. I didn't have any space. I will show it in a different place here. So that this one is nu F. Okay, nu F, and this one is the nu G. And then this is the nu F value, and this one is the nu G value. Let's go to the first value. The first value is 0.0078, and which is less than the saturated liquid nu value. So saturated liquid nu value is here. It is less than that one. You can see the chart axis here. This one is the nu value, and this part is the temperature. If the nu value is less than that one, you are almost here, and it is compressed region. Okay, so the first one is compressed. Second one, the nu value is 0.00065. It is again the less than nu F value. You are here. It is less than that one. Therefore, it is the compressed one. And the third one, which is 0.05, you can see it here. It is more than that one, nu G. It is more than it. So nu G is here. If it is more than that one, you are here, and then it is superheated. Okay. If you have questions, in the meantime, you can ask your questions. Otherwise, I will continue.
VG-nin mən nə olduğunu bir də izah edə bilərsiniz? Mən niyə VG-yə görə götürdük ki orada?
So first, what did you say?
Birinci, ikinci məsələn VF-ə görə götürdük, sonra VG-yə görə götürdük.
Okay, so the first one is the nu F value. This part is nu F. So this one is the saturated liquid. Nu F means, so it starts boiling.
Anlaşıldı.
Nu G means it ends boiling. Here the boiling ends, and here the boiling starts. So the nu F says that saturated region started, and nu J says that saturated region ends. Okay, this one shows the saturated region started, start of saturated region, start, and this one is the end of saturated region. Okay, is there any question? So you are comparing everything with the saturated region. Okay, so you are comparing with the saturated region. If it is less than that one, it is compressed. If it is more than, it is superheated. So here, if it is less than, it is compressed. If it is more, it is superheated. In the mean range, you will have the saturated region. Okay. So then the fourth one, you will have the 0.049402. That is the fourth one. You can see it is less than the nu G value, it is less. Okay, so it means that if it is less than that one, you are here. See, it is less than that region, and then you will be here. So if it is less than nu G, you see it is more than nu F, less than nu G. So it means that you are in saturated region. So this one is saturated region. And the fifth one, you can see it here. So I can ask this question to you. Okay, you can write as a comment. What is the region of the fifth one? What is the region of it? Okay, write as a comment so I can see what are your comments about this one. What is the region for the fifth one? And write as a comment. So let me see your answers. Saturated, compressed also said, no, you cannot have two regions at the same time. You can have only one region. You can have only one region. You cannot have this two regions at the same time. So let's see it, that you can see that the value here, it is the same as the nu F value, same. If it is same here, you are on this line. So you are on this line, you are saturated liquid line. This is saturated liquid, or this one is saturated region, because the saturated region, so it includes the F values and it also includes the G values. If it is nu F, nu G, or it can be UF and the UG. Okay. Therefore, it is saturated region. And now the last one, I will ask you again, the last one, what do you think about the last one? What is the region for the last one? The sixth one. So what is the region? You will just write the name of the region. So the last one. So yes, the last one, this one is the superheated. Why it is superheated? You can see the value, nu G value, it is 0.045. It is given 0.049403. Okay, the value given here, which is 0.08, is more than that one. See, it is more than that one. Therefore, you are in superheated region. Okay. Therefore, this one is the superheated. So we have done the specific volume, we have done the temperature. Now comes the internal energy and the pressure. I will do the internal energy part, then pressure, because the internal energy is the easiest one. The pressure is a bit more confusing, but let's start with internal energy. You will apply the same rule. If it is equal or greater than UF, less than UG, it is saturated, and otherwise you will be in compressed region or the superheated region. Okay, you just compare the values with the UF and the F and the G. These are the demarcations. Okay, let's start with the first one, the 80. So write your comments. So for the 80, what do you think about the 80? Is it superheated, or is it saturated, or is it compressed? So let's see your comments. For the internal energy, so sorry, this one is enthalpy. I should erase it. This one is enthalpy. And we are talking about the internal energy, which is this one. Okay, so first one, Okay, yes, you are right. The first one is so the people said that it is saturated. There are also superheated people. The first one is, let me write it, 65.10. You see, it is the same as the F value, okay? If it is the same as the F value, then you will have the saturated region. Okay, this one is saturated. Now comes the second one. You will tell the value here. What is the value for the second one? So that UF, UAG, the second one, 235.67. So let's see your values. So that people, why do people believe? So you should see this one. You see, if it is less than or equal, or you can see the equality is here. If you have the equality sign, it doesn't change the region. Yeah, I'll let you some more time here. So what is the region for the second one? Equality sign doesn't change the region. What is the second one? Okay, anyway, let me write it. You are wrong, of course. So that, one more time, if it is UF, it doesn't matter, U, nu, etc. For example, nu F, it can be HF, etc. If it is equal or greater, saturated, and again, if it is UG, nu G, and H, you see, equality is here. Equality means it is saturated. So in this case, we can see the saturated vapor, UG. This one is UG, and this one is UF. You see, and this UFG, I've said it, it is the difference. So therefore, you can see that the same value, therefore it is saturated. Okay, now comes the third one. Yes, the third one. Which region is this one? Let's see your answers. The third one. Let's see your answers here. Saturated. Yes, most of the people are right. They have the saturated. And what about the fourth one? 63. 63, yes, let's see your values. Yes, it is compressed because it is less than this one. It is compressed. You can see here. If it is less, it is compressed. If it is more, it is the superheated. Okay, now comes the next one, 255. Let's see your values now. Okay, the people you've got the idea. Superheated, and the 50. What about the 50? Okay, so the most of the people have got the idea. It is the compressed. So that we have finished this part. Okay, we have just the curve. You have the curve, and you are just finding the values. Now comes the pressure one. This one will be a bit confusing, but I will just start with the water, and then I will tell the refrigerant one. So say that I have a water here. The water, that water has a pressure of 100 kilopascals, and it is at, let's say, let me see the water boiling curves here. Just 1 minute. At 50 degrees Celsius, it boils at 12.35. Say that 150. 50, this one, yes, okay. So that 100 kilopascals, the water boils at 100 degrees Celsius. Okay, this one boils. So say that now I have the water, but this time the temperature is 90 kilopascals, and the temperature is, now the pressure is 100 kilopascals, and the temperature is 90 degrees Celsius. Okay, so what is the region for the first one? Is the saturated? It's all clear because it boils. What is the region for the second one? Who will say it? What's the region for the second one? If the temperature is 100 kilopascals, but the pressure is 100, but temperature is less. This one is saturated, and the second one will be, of course, compressed, because this one can't boil. But so I can have another option. Say that now what I'm doing is that I'm decreasing the pressure now. Say that it is 100 kilopascal. So let's see at what just 1 minute that I should look at which. So let me see just the pressure value for the, so it is 70 kilopascals, yes. So that if I decrease the temp pressure to 70 kilopascals, so let's say that T boiling pressure for 90 degrees Celsius, it is 70 kilopascals. So what will happen to the region now? What will be the region? So you can say the region for the third one. So boiling pressure for 90 degrees is 70 kilopascals. It will be saturated. Yes, you're right, genius. Saturated. So what happens is that if you decrease the pressure here, if you decrease the pressure, you don't play with the temperature. Temperature is constant. You see the temperature is constant. I've just decreased the pressure. I changed the region. You see the opposite happens. Instead of increasing, decreasing helps. Why it helps? Because if you decrease the pressure to 70 kilopascals, here you have also 70 kilopascals, it is in equilibrium. So that it means that here the pressure is 100 kilopascals. So the fluid molecules, we have talked about this one in our last lecture, they need some kinetic energy to leave the system. They need some kinetic energy to leave the system. If the pressure is very high, they can't leave it. But if I decrease the pressure to 70 kilopascals, it means that they will have enough kinetic energy to leave the fluid at every location, and then you will have the boiling. That is the essence. What happens when you decrease the pressure? You don't have enough. So pressure presses. Okay, so at the first case, it was about this size of pressure, but when I decrease it, you have the less amount of pressure on the fluid molecules, and then the fluid molecules become free and they leave the system, and it is the start of the boiling. So I will go back to our question here. Now everything will be clear. So that the temperature is 10 degrees Celsius, you see, and the pressure is about this one for boiling. Okay. And in the region here, that you have the region, you see the region here, here pressure is constant. Saturated region here, T is constant and the P is constant. This is the very important one. Now let's start. So it is 10 degrees Celsius. I have decreased the pressure to 414. Now what will be the region? So let me see your answers. What will be the region for the 414 kilopascals? Saturated, there are people compressed. So it can't be saturated. I've said it. If you change the pressure or temperature, you cannot be in saturated region. In saturated region, this one is constant. You cannot change it. So it means that there is impossibility to be in saturated region. Compressed, saturated, superheated. Okay, so the true answer is superheated. Okay. It is very, you know, that if the fluid molecules, let's go back to the water case here, so that now I have the water here. So it is 100 degrees Celsius, but the pressure is 50 kilopascals. Okay. So the water boils at 100 kilopascals. But if I decrease the pressure even less, then it means that it shouldn't boil, it should be in superheat region. Okay. You should understand it, because in saturated region, T and if you are in saturated, T is constant, P is constant. If I decrease the pressure value, then I should be in either compressed region or superheat region. So if I decrease it, then it means that there is less pressure. So this one is the 50 kilopascal pressure. This one is 100 kilopascal pressure. Okay. So if there is less pressure, then the fluid molecules are less free, so more free actually. They can leave the system now. They can leave it. Okay. In the previous case, they were in saturated region. So if I decrease the pressure, they should change the region, because in saturated region, this temperature and the pressure are constant. You see, it doesn't change. So then I should change the region. The logical one says that it should be superheated, because less pressure means the molecules are free to move. They are free to move, and therefore they will have the more energy. So more energy, the more energy means it is superheated. Okay. Now let's do the second one, 415. So P is reversed to T. Yes, we can say, Suleiman, P is reversed to T. So what about the second one, 415? Compressed, superheated. See. Two people said the compressed, and one people says let's say one more person and then finish this one. One more person. So the true answer is, of course, the compressed one. Because if you increase the pressure, it will be difficult. If you increase the pressure, it will be difficult for fluid molecules to leave the system. Therefore, it will be compressed. It will change the compressed region. So what about the third one? What about the third one? 414.88. It is superheated. You see, if you decrease the pressure, less amount of pressing on the fluid molecules, they are free to move. And then what about the, you see, the one value, it is important. What about the fourth one? So what are your values for the fourth one? Fourth one, pressure is 400 kilopascals. For the fourth one, the true answer is, for this one, it is superheated again, because you see, if you decrease the pressure, decrease it, okay? If I decrease the pressure, then it means that the fluid molecules are free to move. If they are free to move, they should change the more energetic side of the chart. Okay, now the fifth one, so this one. What are your ideas? What about the fifth one? So that compressed, everyone says compressed, no problem. And what about this one, the 414.89, the last one? Saturated. Yes, you are right, saturated. You should get it now, saying that the pressure and the temperature are constant for the saturated region. So finish this one, we finish that one, we finish this one, and we finish that one. Only enthalpy part is left. Now I'm going to talk about the enthalpy part, and then we will do some more examples about the charts. Let's go back to enthalpy. So another fluid property, enthalpy. So I will add one more slide here. So 1 minute, dear friends, we are running out of the slides. Or you will have one more question here. Add that question, this part. Okay. At the window. Okay. I should see the screen now. Okay, so this is example 6 and this one is example 7. Okay, now I will first do example 6, but before doing it, I will talk about what enthalpy is. Okay, when we say enthalpy, we are showing with the value of H. Okay, and it is a combination property. So that combination property means that it is combination of two properties. Okay, so one is the internal energy, U, and the one is the pressure and the volume. Okay, so this one is the enthalpy, we call it enthalpy. If you talk about the lowercase letters, so per unit mass, this one is without mass. If you divide per unit mass, first I'm writing the formula, then I will talk about what is enthalpy. If you talk about the per unit mass, then you divide by the unit, if you will divide each term by the mass, it will be U, plus the volume by mass, it will be nu, and this one divided by mass, which is H. So per unit mass, it is enthalpy, and for the general case, that is enthalpy. So firstly, now let's talk about what enthalpy is, and then we will do the examples here. So that enthalpy, so this one is most of the time, let's say that, so mostly used for flowing systems, open systems, let me say, because it will be so mostly. What open system means is that if you remember, so if I have a system like this one, so in that system, you will have some inlet. This one will be the inlet of the mass. So there will be some fluid leaving the system. This one will be the inlet, and this one will be the outlet. Okay. When the fluid enters that system, it will carry different types of the energies. So it can carry with itself the internal energy U. It can carry with itself the fluid when enters to that system. It will carry internal energy U. It will carry kinetic energy V squared by 2. It will carry potential energy Gz. And if you remember the definition of the internal energy, it is sum of molecular energies. Okay. It is sum of the molecular energies, but you should understand this part that molecular energies, these are microscopic, but when you add all of them, you will get the macroscopic quantity, which is internal energy. So you don't feel the energy of the molecules. So what are the energy of the molecules? They can translate from one location to another, they can vibrate, rotate, etc. But when you add them, you will get a macroscopic quantity, which is internal energy. Okay. And most of the time, it's a function of the temperature. Okay. If you increase the temperature, internal energy increases. So when the fluid enters to the system, this one is fluid, it will carry with itself the internal energy, it will carry with itself the V squared by 2, which is the kinetic energy, Gz, and it carries with itself with one more energy. Okay, that energy is called flow energy. So I will not give the formula what flow energy means, but the flow energy, so in simple terms, it means that when the fluid moves, so let me give a formula here so you can see what I mean. So that this is the part that the fluid will enter, okay, with some pressure of P. It has some pressure. Let me show it in a different case here. This is where the fluid will enter. It will have the pressure of P. And when it enters with this pressure, and it will apply the pressure to this area. Okay. This part is the fluid. It is very similar to stress. Okay, pressure is stress. And when it enters, the fluid enters, it applies a pressure on the rest of the fluid that is inside the vessel. Okay, and this part will have an area of the A. So this fluid will have a pressure P. It will apply this pressure over an area of A. So force due to entering fluid. Okay, the entering fluid will have some force which will be the P into area. Okay, this one is clear. Now we are talking about the energy. So this entering fluid will apply this force for some length. Let's assume that this is the length that we'll try to apply. Okay, we can see it now. So it will apply this pressure over some length of L. Okay, so it will be the energy due to P to enter, the energy due to P to enter the new system. It is the new system, I mean that this one, okay, this vessel. Okay, the energy to enter that one will be PA multiplied with the L. Instead of the A in the L, you can write the PV. Okay. So what it means, when the fluid enters, it displaces this amount of volume to make a space for itself. So when the fluid enters, it displaces V amount of volume with applied pressure P to make a space for itself. So when the fluid enters, it applies some pressure P over an area A, and it displaces a distance of L. Therefore, when it enters, it displaces this amount of volume here. You can see this amount of volume. It displaces this amount of volume, and with applied pressure P to make a space for itself. Okay. Therefore, so this one is that general energy will be PV. Okay. So we have the internal energy, we have kinetic potential energy, and the energy that is required to make a space for itself inside this vessel. Okay? That is the PV. So the sum of this U and the PV is called enthalpy. This one plus that one is called enthalpy. It is a combination property. It is just the name of it. Okay? And the U plus the P nu, it is also the enthalpy here. Okay? In simple terms, you can say that the enthalpy is the sum of the internal energy and the flow energy, or the energy that is required to make a space for itself in the new system. Okay, so this is the fluid property, which is the enthalpy. Now what I'm going to do is, now you will use the enthalpy. You will find, instead of working with this one, instead of working with that one, so we are working with we are finding all of it together, because this combination frequently happens. This combination frequently happens. Therefore, instead of calculating this one, calculating that one, we are calculating the combination one, which is the enthalpy. So the question says that how you think the enthalpy value is calculated in the table. Take one table as an example and find 3 enthalpy values by hand. Give the definition of enthalpy. So I've given the definition of it. Now we will calculate one enthalpy value. So I will do one of it, not 3 of it. I will do one of it from the table, and you will see what enthalpy, how enthalpy is calculated. So I will go back to the value here. This is given in the question. So they have given HF value, they have given the HG value. Okay? So I will calculate the HF, or you can also calculate the HG here. So first I will calculate the HF. HF will be equal to U plus P nu. Okay? But you should be very careful here. You should add the UF, because we are working with UF, and you should be nu F. There is no pressure F value. There is no, it is all about the P and the U and the nu. And the UF value is, if you go back to this chart, UF value is 65.10. This is the UF value. Unit is kilojoules per kilogram. Pressure value is 414.89. 414.89. This one is the kilopascal, multiplied with nu F value. Nu F value is 0.0007930. So you will have 3 zeros. You will have 79 and the 30. It will have a unit of meter cubes per kilogram. Okay, so if you do this calculation, you can do it by yourself. If you have the answer, you can tell me, or say yes. Somebody asks the meaning of the nu. Nu is 1 by rho. We've talked about this one in our previous lectures. The opposite of the rho. So what is the value of it? If you have the result, you can tell me, or I can do it. So it will be so. Yes, most of you have got the value. So let me write one by one. 65 plus 10 plus, yes, you have got the value 65 point, yes. You will have the 9. So I will work with the same number of units here. So it will be 0, 0, and then 3 and 4, 7. 3 and you will have 7 and 8. So if I add it, so you have got the values there, all right. So 65.42900. So it will be, okay, it's enough, I think. So this is the enthalpy value. So if I go back to the chart here, so unit also, I should add the unit, which is kilojoules per kilogram. I should go to the chart here, and you can see the enthalpy value here, which is given at 65.43. It's 65.43. See, it is the same one. So how they are calculating the enthalpy values, they are just adding the U value here, which is internal energy, with the nu F value here, which is this one, multiplied with the pressure value. Okay, so this is the enthalpy. So one more thing about enthalpy here is that similarly with the internal energy, enthalpy HF, so this one is the saturated, and Hg. Okay, this is in this region, and the superheated one, it is more than Hg, and the compressed one, it is less than Hf. So with this one, let's do this column here. So the first one is 80. You will just say me the name of the region. So the first one, 80. You will just say the region. If the enthalpy is 80, what region are we in? So you will see the 80, so you can see the enthalpy column here. Enthalpy is here. This part is the saturated enthalpy, and this part is the vapor, saturated vapor. This is the G part, and this is the F part. So what will be the region? So that 80, saturated. Yes, you are right, it is saturated. Now the second part, 65.42. 65.42, you will have it. So that compressed. Yes, all of this is compressed. What about the third one, 256.16? Yes, it is most of you have said it, saturated. So it includes Hg. Okay, I've said it multiple times. One more time, it doesn't change anything. So saturated means it includes. So the last one, now the fourth one, 500. See your values. Yes, you've got the idea. Yes, it is superheated. So this one is also superheated. What about the last one? 6, compressed. Yes, all of you said it is compressed. You're right. Okay, this is the enthalpy. So we have finished enthalpy 1. So you see this is how we define the regions. You have the 3 regions. One is the saturated, one is the compressed, and the other one is the superheated. And you have also the F value, G value. I've said it multiple times. F is start point of the boiling, G is the end point of the boiling, and here you have the mixture. So you have the mixture here. Find the enthalpy of water at 0.18 megapascals and 500 degrees Celsius. Let's do this part. We have done the question number 6. This is okay. We have done it. Now the question is for that one. How can you do? So firstly, I will add one more. So yes, this part is okay. I will just write it 0.18 megapascal, 0.18 megapascal, which is 180 kilopascals, and this one is the pressure, and temperature is 500 degrees Celsius. Okay. So at this pressure and the temperature values, the question asks me to find the enthalpy value H. Okay. So to find any property, so now I'm going to use table. So I'm going to use table. So to use the table, so to use any table, so I will show it, but you should know the first step. The first step is to always we should look for the saturated region. Saturated region means that the tables, let me go back to, I've written the number of the tables, A4 and A5. For water, you have the A4 and A5. So any of it is okay, but you should go A4 and A5. Now I am switching off the screen to the tables. Now you can see the tables in the screen. Just 1 minute. So you will have the tables on your screen. If you look at it, you will have the tables. So what I'm going to do is that I will go to the beginning of the table. You can see here, I'm looking for the saturated region. You see, it's only saturated. The first step is only saturated region table. saturated water, you can use A4, you can use A5. Doesn't matter, it is the same stuff, but for A4, the temperature is the preferred one. It means that the increment in temperature is preferred. For the A5, pressure is the preferred one. So here you have the most of the values of the pressure, but here you have the most of the values of the temperature, good values. Here you have the good values for the pressure. For our case, I'm going to use A4. As I said, it doesn't matter. So I'm going to table A4. You can see the names of the tables. This one is table A1. And I'm going to the table A4. Let me go back to the table A4 here. A4, you see? This one is the A4. And the question says that find enthalpy value for 500 degrees Celsius and the pressure is 180 kilopascals. Okay. Now we should find it. Let me go back. The temperature is, go back temperature value again, 500 degrees Celsius. So this one ends. Then let's go back to, so you see that there is no temperature for that one, 500 degrees Celsius. But so this is a different question, but to make you confuse a little, but I will go to the pressure value, which is 180 kilopascal. For 180 kilopascal, you have the almost here, okay? And the temperature is 500 degrees Celsius. We don't have 180 here, but you can approximate from these values, 175 to 100. And if you had the 180 here, you will have it. So if you had in this range, and the temperature is 500 degrees Celsius. What do you assume that the region will be? Is it superheated, or is it saturated, or is it compressed? So temperature in our case is 500 degrees Celsius, pressure is 180. What do you think the region will be? Is it compressed, superheated, or saturated? So it is superheated. Everyone, two people says it is superheated. Superheated, yes, you are right. If you have the temperature of the 180 kilopascal and the temperature is 500 degrees Celsius, you can see the temperature is more. If it is more, it is superheated. Then I should go to the superheated table. You can see that it is again saturated. I'm going to superheated table, and what I'm looking for, the pressure value. You can see it is 0.01. It is not, I'm looking for 180 kilopascal or 0.18 megapascal. See, it is again a problem. It is not here. But to make the things easier, here you should do double interpolation. But to make the things easier, firstly, I will make it as, so I should go back to the slide. I will switch the screen. So I will make the question a little bit easier because I don't want to start with the double interpolation here. So you should see the screen now. You can see the screen. So here in this case, this one, it will require double interpolation. But before doing double interpolation, I will do the linear interpolation, one step. Okay, to make it one step, I will make pressure as 0.2 megapascal, but the temperature as 550. Let's say 560 degrees Celsius. 560 degrees Celsius. With these values, I'm going to ask you the enthalpy value. And you have said it for this pressure, or this one's 200 kilopascal, it is superheated. And then I'm going to look at the superheated table. So let's do that. So I will switch the screen again. I've changed the value here. So I'm presenting you the table window. You can see it now. So you can see the screen with the table value here. So I'm looking for 0.2 megapascals and 550 degrees Celsius. What I will do is I will take the screenshot of this page. I've taken it, so I will copy it to my presentation. here, and I will change the window back to the presentation. So that we can move on to the... Okay, now you can see the screen now. So you see, we have the pressure value, which is 0.2 megapascals. It is here, it is 0.2 megapascals. And the temperature value is 500 degrees Celsius. And what we are wanting is H value. So from the table, the first one, so at the top of the table, first one is the temperature. The second one is the mu. It is from the table, okay? I'm just copying the table. Third one is internal energy, and then you have the enthalpy, and then you have the entropy. Okay? I'm looking for the enthalpy column, which is this one. Okay, enthalpy column is this one. And I'm looking for the 560. Okay, I'm looking for the 560. I have the 500 here. I have 500 here. I have the 600 here, but I don't have the 560. Now I will do the linear interpolation that I think you should know it from the material science. Let's do it together. So linear interpolation means that this part, let's say, is the temperature or enthalpy, and this part is the temperature. And for the temperature of 500 degrees Celsius, if it is 500 degrees Celsius, and the enthalpy value, it is given as this one, 3000, so that 87.7. So if I move on the next line, which is 600 degrees Celsius, so this part is the 3000 actually, 704.8. This is the enthalpy value. Now I'm trying to find the enthalpy value here. Let me use a different color here. So this part, 560 degrees Celsius. I'm trying to find what is the enthalpy value here. So to make it, so how can I find the enthalpy value here? I will make an assumption here. That assumption, okay, H versus temperature is linear. H versus temperature is linear means that this one is linear one. Okay, if it is linear one, then what I can do is that I can make the line here, and I will find what is the enthalpy value here. So that, okay, so let's do it. So that 600 minus 500, 600 minus 500 divided by this one, 8 minus that one. So difference in between here and difference in between that one should be equal to the second one, 560 minus 500 divided by x minus 3487.7. This is just a linear interpolation that if you know the f is kx plus b. Okay. And these values that I'm trying to find are the k. Okay. If whatever difference you get from that one with this one, you should have the same k's. It doesn't matter. If you do that, you will find the value of the x. Of the value, you can tell me, I can write it and finish today's lecture. Okay. If they have the value, you can tell me, I can finish the lecture. Otherwise, Rajab says that I have the value here, that x value becomes 3617.96 kilojoules per kilogram. Okay. And this one is interpolation. Interpolation, because you are interpolating. Okay, you are interpolating with the two different values. But it is not the exactly interpolation. It is linear interpolation, okay, because you are doing in a linear manner. Okay, so I'm starting the recording here. Next lecture, I will continue from this point on.